An electric car, or electric-powered car, is a vehicle that runs on electric motors powered by electricity stored in batteries. Unlike gas-powered vehicles, electric vehicles, EVs, do not require internal combustion engines to operate. Equipped with an electric motor and rechargeable battery pack, EVs run on the roads without burning gasoline or producing harmful exhaust emissions. And they also generate less noise pollution. Here's how electric cars work. EVs draw energy from a charging station, which is stored in their battery. This battery powers the electric motor, which turns the wheels. Several electrical components work together in the background to make this motion possible. Friends, welcome to Canna Tech YouTube channel. This is our first English vlog of the channel. This channel is dedicated to the ancient Indian scientist Kanat, who was the first in the world to theorize the existence of atoms. Please subscribe to our channel. It would be a great support for our channel. Main components of an electric car. Charge port. An electric vehicle's charge port allows the battery pack to receive energy from an external power source. These power sources are called electric vehicle supply equipment, EVSE, commonly known as charging stations. Charging occurs when an EVSE is plugged into an EV's charge port, whether at a private residence or a commercial charging station. For example, an EVSE using a standard 240-volt outlet, similar to what's used for household appliances, can charge an EV overnight. DC fast charging. Inside the charging station, AC power is converted into DC power and then delivered directly into the EV's battery pack. This process is significantly faster than Level 1 and Level 2 AC chargers. Such fast charging stations can charge a traction battery pack in approximately 15 to 45 minutes. Charging an electric car is more complex than it may seem. That's why these cars include a dedicated electronic unit to manage the process. An electric car must be capable of charging from multiple sources, ranging from a basic home socket to high-powered charging facilities developed under various standards: European, American, Japanese, and Chinese. Unfortunately, there is currently no single global standard for charging stations. Some systems use AC, alternating current, to charge batteries, while others rely on more powerful DC, direct current, which bypasses the inverter almost entirely. The method of charging also affects how long it takes to fully charge the battery. Inverter. In an electric vehicle, the inverter converts the direct current, DC, from the battery pack into alternating current, AC, which powers the electric traction motor. Since lithium-ion batteries can only store and deliver DC power, while electric traction motors require AC power to function, the inverter is a crucial component of any EV. The inverter also regulates the frequency of the AC power sent to the motor, playing a direct role in controlling the EV's speed. The inverter connects the electric motor and the battery. As its name suggests, its main purpose is to convert current, since the battery deals with DC, and the motor operates on AC. However, this box has a much broader role. It controls the forward acceleration and deceleration of the electric car via the accelerator pedal. It also manages energy flow from the battery to the motor and, in regenerative mode during braking, from the motor back to the battery. Electric traction motor. The electric motor is the core component of any battery electric vehicle, BEV. It operates on the following principle: when a current-carrying conductor is placed in a magnetic field, A mechanical force acts upon it, rotating its shaft. This motion is the result of electromagnetic interaction between the moving component, rotor, and the stationary part, stator. There are various ways to achieve this, so electric motors come in different designs. Brushless motors are commonly used to power electric cars. A highly efficient example is the synchronous AC motor, which uses permanent magnets in the rotor. It does have drawbacks like cost, since manufacturing these magnets involves rare earth metals. Secondly, control complexity, due to the permanent magnetic field, making precise speed control operation more challenging. Therefore, this type of motor is typically found in high-performance electric vehicles such as the Porsche Taycan and Tesla Model S. The electric traction motor essential for propelling an electric vehicle usually runs on alternating current, AC, as it is more efficient and reliable compared to DC motors. When AC current reaches the motor via the inverter, it generates a rotating magnetic field that turns the motor. Electric traction motors are highly powerful and fast, with near-instant torque transmission from pedal to tires, unlike internal combustion engines, which require multiple gear changes. Gearbox. Electric motors used in electric cars produce a high amount of torque. They can start spinning at high speeds instantly and even reverse direction. That's why electric cars don't need complex multi-speed gearboxes or bulky transmission systems, like used in the internal combustion engine vehicles. Instead, they use a simple and reliable reduction gearbox, often planetary gear, directly connected to the motor. However, powerful and high-speed cars may sometimes include a two-range gearbox to support both strong low-speed traction and high maximum speed. Traction battery pack. The main function of an EV's traction battery pack is to store energy received from the grid during charging. This energy powers the motor and all other electrical components of the vehicle. Almost all EVs on the road today use lithium-ion batteries in their traction battery packs, due to their high energy density compared to other battery types. Lithium-ion batteries not only can produce more current but also require less maintenance than other types. Some EVs also include an auxiliary battery, which powers the vehicle's accessories so that the traction battery isn't burdened. Cooling system. Electric motors generally produce less heat and don't need a very powerful cooling system. However, every battery electric vehicle, BEV, includes a radiator and heat line system, primarily for the traction battery. That's because the traction battery performs best within a specific temperature range. Under heavy loads, repeated discharge charge cycles, or during high-speed charging, the battery can become very hot. The inverter also handles significant current, so it also requires temperature control. Brakes. In theory, a battery electric vehicle, BEV, could operate without a traditional braking mechanism, as the electric motor in generator mode provides braking through resistance. However, in practice, all electric cars still include conventional braking systems like brake pads, discs, water pipes, and hydraulic fluids. Since regenerative braking reduces the load on brakes, wear and tear on brake components in EVs is much slower. Electric powertrain. The EV powertrain refers to the entire high-voltage electrical system that enables the vehicle to operate. A standard electric powertrain includes inverter, electric traction motor, reduction drive, and traction battery. These electric powertrains are lightweight, compact, and have minimal vibration while offering instant torque. Many inverters are also capable of energy recovery during vehicle deceleration. This process is called regeneration, where excess AC power during braking is converted back into DC and stored in the battery pack. Let's end this vlog here. Let us know in the comment below how much mileage your EV car is going on a single charge. We thank for watching this video till to the end. Please subscribe to this channel to get notification for the next vlog.